Hi students, this is Mrs. Foy and we're going to do another quick tutorial on nomenclature. This time we're going to talk about using polyatomic ions in your formulas and chemical names, and we're also going to talk about transition metals. Alright, so over here we have a list of some cations. Those are positively charged ions, and some of these you see are just regular single ions, and there you see ammonium is one of your polyatomics that you have to memorize. And here are some anions. Some of these you already recognize, like nitride and sulfide, but here are some polyatomics, right, like nitrate, sulfate, and phosphate that you should recognize. And then here are a list of some examples of transition metals. Transition metals are in that center section of the periodic table that are in the shorter columns, and they are metals, so they do form cations, but they have variable charges. So you can see here's copper. Copper can form a +1 ion or a +2 ion under certain conditions, and iron can form a +3 and a +2 ion. So let's see how we would put these together to make some formulas. Okay, so over here I've got my cations, which are my metals, and my anions, which are my nonmetals. I'm gonna make calcium sulfide. So I'm gonna grab calcium over here, and I'm gonna grab my sulfide here. So you can see in ionic compounds, right, those positive and negative charges have to balance out, and I can see that those do. And so I don't have to add any more. I can just go ahead and make this calcium sulfide, and that would be CaS, right? So calcium sulfide would be CaS because the charges already balance out. Okay, cool. All right, so let's drag this up here and let's leave calcium, but this time let's use a polyatomic. Let's make calcium bond together with sulfate. So here's calcium, and this is sulfate, a polyatomic ion. I see my charges are still going to balance out, so I'm going to call this calcium. Let's make this a little bigger here. I'm going to make this CaSO subscript 4. I have to keep that because that tells me how many oxygens go with that polyatomic ion. And this is calcium sulfate, okay? Okay, so let's do one where the charges don't match up, all right? So let's make calcium bond together with phosphate, all right? So here I've got my calcium +2 and my phosphate +3. Now, do you guys see that I'm going to have to add 3 more of these calciums and 2 more of these phosphates to be able to get +6 and -6. So what my formula is going to look like is I'm going to have to use parentheses around this polyatomic ion. So what I'm going to make here, my formula is going to be Ca parentheses, well actually Ca subscript 3, because I need 3 of those, and then parentheses PO 4, and then I need 2 of those, and this would be called calcium phosphate. Okay. So I would need a total of 3 of these, and I'd need a total of 2 of these to make +6 and -6, and that's where I see here. I don't need a parentheses around the calcium because it's just a single anion, a single cation, so that I need 3 of those. But I do need a parentheses around my polyatomic ion because I'm saying I want 2 of the whole phosphate polyatomic molecule itself. All right? Now, I can also do this with my my one polyatomic cation. So I'm going to drag ammonium down here, and let's make ammonium sulfide. All right? So you can guess what's going to happen, right? I have a +1 and a -2. So does everybody see I'm going to have 2 of these positive cations to balance out the charge on this 1 -2 anion that I have. So I am going to write my formula. I'm going to need a parentheses, right? Because it's going to be around a polyatomic ion. So I'm going to say parentheses NH subscript 4 because that is the formula for ammonium. And I need 2 of those. So I need 2 of those, and then here comes my sulfide. And so this is ammonium sulfide. Ammonium sulfide. All right, and I see the parentheses there around my polyatomic ion. Okay? Pretty cool, right? All right, so now let's see what's going to happen. Now I'm going to use some of my transition metals. And with transition metals, what you do is you use Roman numerals to tell you the charge on your cation. So for example, if I wanted to make copper 1 sulfide, all right, copper 1 sulfide, okay, so here is my copper 1 and here is my sulfide, right? All right, so I have a +1 and a -2, so I'm going to need 2 of these coppers, right? Don't need a parentheses because it's not a polyatomic ion. So I'm going to write Cu subscript 2 sulfide. Okay, so here is copper 1 sulfide. All right, well, cool. Suppose I want to make copper 2 sulfide. All right, so I'm going to grab my copper 2, and look, my charges are going to balance out, right? So this is going to be an easier formula to write. I'm not going to need any subscripts. I just have 1 copper and 1 sulfide, and I would call this copper 2 sulfide. Okay, so that's copper 2 sulfide. Here's my copper 1 sulfide and my copper 2 sulfide. Let's do one more. Let's make an iron 3, and let's use a polyatomic ion this time. All right, let's have nitrate, and let's make iron 3 nitrate. All right, so I want to make iron 3 nitrate, iron 3 nitrates, not nitride, because I've got a polyatomic ion there. So let's see, I've got a +3 and I've got a -1 over here. So I obviously need 3 of these, right? But I am going to need, oh wait a minute, this is iron 3, and a Roman numeral 3. So I'm going to need 3 of these nitrates to balance out with my 1 + 3 iron, and I'm going to need a parentheses when I write my formula. So I'm going to do Fe parentheses NO subscript 3, close parentheses, and I need 2 of these, right? 2 of the whole thing. So this is iron, nope. I need 3 of these, iron 3 nitrate. And that's how you do that. Good luck practicing. See you in class.